3. So, all right. So there's going to be some terms that we're going to go over. What happened here? I had a dead battery. All right, well, I'm teaching from here. Miss Miller, I can't sit next to you. I have to be connected to a power source. I'm sorry. All right. And then Control K. That's 8. All right. Now we're ready to go. Sorry, I don't know why this wasn't charged, but I had it plugged in, I promise. Okay, so we're going to go over a couple of definitions. And, yeah. Okay. So a relation. This is like ordered pairs or points or a table of values. Okay? Hey, Bob. We're on page 93 when you get there. Bless you. All right. So a relation, could honestly be like 3, 7, 2, 6. It could be a table of values like x, y, 1, 2, 7, 10. Okay? Just table of values. That's all it is. Okay? A function is a special relation. It's a special relation. Okay? If we were to look at a point as an x, y value, a function does not have repeats of the x. Does not happen. Okay? So a function is a relation that the x values don't repeat. What about the y values? Well, I'm not worried about those. The x values don't repeat. Okay? Does this seem okay so far? So the x and y values just x. Hey, how are you? Good, how are you? Doing well. Gotcha. Thanks. All right. Free Starbucks gift card. Not telling. Not telling. I'll get it to the person in a little bit. All right. Can I move off the screen? All right. The domain is a fancy way of talking about x values. The range is a fancy way. Fancy. Talking about y values. And I kid you not, when you have x, y, the x is the domain and the y is the range. It's as simple as that. Now, how I remember domain and range, x, y is alphabetical. X comes before y in the alphabet. Agree? D comes before R in the alphabet as well. So if it says, hey, give the domain and range, you're like, I don't remember what domain and range are. X and Y are alphabetical, so domain and range are also alphabetical. Okay? All right. So you might have seen this before. These are just like bubble diagrams and tables. Okay? So we want to know if it's a function or not. So I said a function has what values that don't repeat? X. Do any of my x's repeat here? So this is a function. But take a look at this one. I have 1, 20, and then I have 1, 8. Does my x repeat?
Yes.
This is not a function. And then for this next one, I have 1 comma 10, 2 comma 10, 3 comma 10, 4 comma 10, 5 comma 10. The y's are repeating all day long, but not the x. This is a function. And then take a look at this table. Why is that? Yeah, so the 1 repeats, so that's not a function. Again, I'm not worried about y values repeating. Okay, that becomes a specific type of function. We're not worried about that. We're not going to have to know that it's a one-to-one function. We don't need to know that. But x values repeating means not a function. Yeah.
So a function is
The x values. If the x values repeat, you don't have a function.
So I would write that on the side of your notes, like where it says function versus function, not function. Write either underneath function, x should not repeat, or does not repeat, or x is whatever works. Okay. Then under non-function, x repeats. That makes sense. Okay.
I feel blessed. Okay, function, no repeat x, not function, x is repeating. Okay, all right. So that I think everyone will like this. Vertical line test. If I draw a vertical line through any of these values, so those first two, notice it crosses twice. Notice it crosses twice. Vertical line, straight up and down. Okay, this is not a function, and this is not a function, because if I found those exact points, I would have a repeat of my x values. But notice this one. I can draw a whole bunch of vertical lines here. The vertical line never crosses the picture more than once in any one vertical line. So yes, this is a function. Okay? Vertical line test, pretty simple. Okay? I give you a picture. Hey, is this a function or not? Nope. Why not? Didn't pass the vertical line test. Yes. How do you know? Pass the vertical line test. Yeah.
so those like verticality basically.
Do what?
So if it's a function, not a function, there's you imagine like a vertical line and then that one thing.
Yeah. If that vertical line, if you could draw a vertical line anywhere on your XY axis, and that vertical line happens to go through two different parts of the graph or two identical points where the x value is the same, that means you're not talking about a function. This isn't too bad, I don't think. So we talked about domain, range, relation, function. Next page. All right, let's see. So is this a function? So it's kind of hard sometimes to look at an equation and realize you have a function or not. So I want you to think about this. If you're not quite sure, pick numbers that are around 0, 0. Okay? So could I plug -2 in? Could I plug -1 in? Could I plug 0 in? Could I plug 1 in? Okay? A lot of times in this class, things that define that not being a function will happen around there. So let's think about this. If I replace these numbers in for x, do I get a different number out each time? So 2 times -2 plus 3, that gives me -4 plus 3, which is -1. If I take -1, plug it in, 2 times -1 plus 3, 2 times -1 is -2 plus 3, -2 plus 3 is +1. If I plug 0 in, 0 plus 3 is 3. If I plug 1 in, that gives me 2 plus 3, which is 5. If I plug 2 in, that gives gives me 4 plus 3, which is 7. So my friends, does it appear any of these have repeated? Is -2 the same thing as +2? Two different numbers, agreed? Okay. So then we create something where we do f at x. That's f at x. Some books call it f of x. They mean the same thing. This is a fancy way of writing y. Fancy way to write y. It's called function notation. Okay? So you might see f at a number or f at a letter, f at x. You might see g at x. You might see h at x. Okay? That's functional notation. Okay? So this is inside the parentheses, so this is what you plug in. If you see something outside, you solve for x. So two kind of sort of different things. I kind of wrote a whole bunch down there, so I'll give it a moment to pass on by.
Any questions? That is like, that doesn't make sense. Yeah.
So on that first one, where's that table like?
Oh, I was just seeing, could I plug these values in and get a value out? So if I had graphed this, and you don't need to know how to graph yet, if I graphed it, it would look like a straight line. That's what the graph would look like. That's why it says think about the graph, but we haven't touched how to graph yet. But you've probably seen graphing at some point in some other math class. All right, got another minute to make sure we get our thoughts collected. Ready? Here we go. All right. So I'm going to highlight a couple of things first. So I have an F, I have an F, I have an F, and this one is also F at X. These are all going to be related to this problem. Then I have a G, I have a G, I have a G, I have a G here. That's going to be related to this problem. So I have the pinks and the yellows. Okay? So let's see if we can work through this. F at 1, this means replace X. So I'm going to say F at 1 is equal to -3 minus 2. What lived where these parentheses was in our original? What lived in these parentheses where this, what used to live there in the original? What used to live there? I'm underlining it in blue. X. X no longer lives there. 1 lives there. So then I go -3, because -3 times 1, minus 2, so I get -5. So this yields me the point 1, comma, -5. Okay, now let me pause there.
So I know a lot of you are probably like, well, this is a whole new concept. It's really not. It is a new concept, but it's not. Have you ever, you know how at the very, very, very beginning of the year, we had, oh, by the way, X is equal to 3. And you guys just plugged it into the equation? Do you kind of remember that? That was kind of, it's exactly like this. So whenever you have F, like, that's kind of the concept, if that makes sense. So it's new material, but it's not new material. It just looks a little different, yes.
Morgan, are you on task?
Yeah. And you have to follow it because if you have, like, for example, number 1, it says F parentheses 1, then that's stating you're replacing it. Now, if you had something outside the parentheses, that is a little different, if that makes sense. Okay?
All right. So I feel like standing. All right, so let's take a look at this one. 0. What did I do on this first one with the 1? What do you think I do on the third one with the 0? Yeah, so this is going to be equal to -3 times 0 minus 2. Where that 0 is where x used to live. Now it's going to be a 0. So what's -3 times 0? 0. What's 0 minus 2? So it's -2. So what point does this yield? Look at what the point this yielded. 1 comma -5. So what point is that going to yield me? Very good. 0 comma -2. Okay. All right. For problem number 5. What am I going to do with this -1? So I'm going to go -3 times what used to live in these parentheses? X. What's going to live there now? -1. Okay, I'm going to replace x with the -1. What's -3 times -1? +3. What's 3 minus 2? 1. What point is this going to yield me? -1 comma +1. Okay. All right. Do you feel comfortable so far with the yellows?
No.
Where were you stuck? I'm just replacing. I'm putting something in.
So if you guys are getting, because a lot of people are getting confused with this. So what I like to do, because I'm a cover person, is I'm like, okay, I have f -1. Okay, I'm gonna look up here. Okay, f, and I have this parentheses. Okay, I'm gonna cover this. Now this is the equation I'm gonna work with. So then I take that equation, bring it down, and then I'm like, oh, f is in those parentheses for x. Okay, I'm gonna replace that with -1. That's how I do it. I cover it with my thumb. So then I'm like, okay, that's the equation I'm focusing on. That's an easier way.
Yeah.
So it's the same.
Yes, it'll be the exact same. But I want to go to number 7 first. Take a look at number 7. Does number 7 look like it's written a little bit differently than 1, 3, and 5?
Yes.
Do you agree?
Yes.
So what this means is this says f at x is equal to -8. Look where f at x exists. It's where y would have been. Agree? So I'm going to take this equation, I'm going to go -8 equals -3x minus 2. Now I have to solve that for x. So how do I solve that for x? What's the first step? Close? Add 2. Good. I'm going to add 2. Add 2. Those cancel. -8 plus 2 is -6 equals -3x. How do I get x by itself if I have -6 is equal to -3x? Divide by? Close? Not 3. -3. Thank you. You said -3 originally. I'm sorry. I just didn't hear the negative. Okay. What's negative over negative? Positive. What's 6 over 3? +2. So I get x equals 2. So this will yield me the point 2 comma -8. Done. All right, let's switch colors. Go green. All right, so I'm no longer using the yellow. I'm going to go to the pink. Does that make sense? So I have g at x. Notice g at x and f at x. This is still what y used to equal. All right, so what do you think I should do with the 1 on the pink equation? So close. I'm plugging it in. Okay, so this is going to be equal to 10 times plus 2. So what used to live in those parentheses? What was originally on the pink? What was originally on the pink? X. What's going to live there now? 1. So 10 times 1? 10 times 1? 10 plus 2? So I get 12. What point does this yield me? 1 comma 12. Very good. Okay?
Wow, this little space that makes
Why
are you making it so tiny?
All right. What about number 4? What should I do with g at 0 with the pink equation? Plug 0 in for x. So 10. There was parentheses here. What was living where the parentheses are right now? X. What's going to go there now? 0. What's 10 times 0? 0. So I get 0 plus 2 is 2. So what point is this going to give me? 0 comma 2. Very good. Almost done. Number 6. Yeah.
Never mind.
You got it? Okay. Number 6. What am I going to do with the negative 1 on this one? Plug it in. So this is equal to 10 times parentheses plus 2. What used to live where the parentheses are right now? X. What's going to go live there now? Negative 1. 10 times negative 1? Negative 10 plus 2? Negative 8. What point? Good. Whoops. Negative 1 comma negative 8. This delay is
Killing you.
it goes faster when I have the tablet. All right.
And if you guys are confused with the parentheses, remember when we think about graphing, in our parentheses, it would go x comma y, okay? So, for me, I had to think about it. I was like, okay, why do we have 1 and 12? That doesn't make any sense. And then I had to go back and think, okay, we're solving for, when we plug it in, that original, like, G for number 2, G1 is like our x in our parentheses. And then once we solve it, that's going to be our y. So that's why it would be 112. Okay?
Does number 2, number 4, number 6 look a little different than number 8?
Yeah.
What do you think I should do for number 8 that's different than 2, 4, and 6? I'm going to replace what with what? I'm going to replace g at x with, I'm going to replace this with 32. Okay? I'm going to go 32 equals 10x plus 2. Notice I did not replace the x. I replaced the g at x. I replaced where the y value would be. Solve this. Minus 2 minus 2. Let's cancel. 30 equals 10x. Anyone want to take a shot at what x equals then? 3. So if x is equal to 3, my point would be then 3 comma 32. Woo. That's a little thicker. Thanks for tolerating me writing on the other board. It's kind of cool. It shows up all over. And showed up on the tablet too. Look at how fancy.
Tablet just dead. Is that why?
No, the tablet's on. It's just I didn't want to sit.
So if it has an answer, we just use the base problem.
Huh?
So if it has an answer like 32, we just use the base problem.
Yeah, you do the problem, and then what I'm trying to get you to realize is anytime I plug a value in, if I plug a value in, I have an x and a y value that I get out. An x and a y value is a point. Can I move on? All right. Take a deep breath. Okay? So, looks like we have a heart rate on this first one. They have the time in minutes, and then they have the beats per minute. So this is some sort of graph or something. And then this is water level in a wading pool. So this is the depth of inches of the pool. This is the time in hours. Well, shoot, what does this seem like this is happening in this case? Yeah, I got a hole in my pool. Oh boy. And then someone stuck their finger in and stopped it for a minute. Then they peed in the pool and then started. Sorry, you can't take stirrup anywhere. All right. So hang on. Go back a page or so. The domain was what value? Fancy way of saying x. Okay. The x on this one would be our time in minutes. Our time in minutes. What was the range?
Y.
The y values. Fancy way of saying y. So this is beats per minute. Okay. Now, before I go further, I'm going to talk about the domain of this other one. What's the domain on the swimming pool? What's the x value? Time in hours. What is the range? Depth in inches, right? Okay. Bring this down a little bit more. I'll try and keep my graph in place. All right. Increasing and then decreasing. Increasing. Decreasing. I think I know how I'm going to do this. Let me do this with a highlighter. Increasing here, here, here. Increasing only here. Okay. So the increasing is the yellow. We'll do decreasing in blue. So decreasing here, here, and here. Decreasing here, here, and then here. Okay, so I have different colors up there, agree? We have increasing versus decreasing. Okay. Let's see if we can convey this a little bit. Okay. It's increasing. I'm going to look at these values here. It's increasing from, is that a solid dot right there? Is there a solid dot on the very beginning?
No.
So a solid dot means what kind of bracket? So 0, and it's increasing all the way until here, which that's 15. Okay? From 0 to 15, it's increasing. Now, I don't want to double count a point, so I have to pick. I'm going to make this one a soft bracket because for the decreasing, it'll be a hard bracket. And then I'm going to talk about where it's increasing again. So it's increasing from here to here. So from 20, whoops, give me that. It's 20 to 30. So I'll have a hard bracket on the 20, a soft bracket on the 30, and then it's also increasing from here to here, so that looks like 35 to 50. All right, now let's talk about decreasing. It's going to decrease. It's going to decrease here. So from 15 to 20. Remember I called the 15 up above a soft bracket? I'm going to call it a hard bracket here. 15 to 20. Okay. And I have a soft bracket on the 20 because notice I had a hard bracket on the 20 here. Okay. And then it's also decreasing here. So from 30 to 35. And then it's also decreasing from here to here. So from 50 to 60. Is that 60 a solid dot or an open dot? Solid. Okay. Ooh, that's a little different. Let's see if we can figure out the same thing on the other one. It's increasing from here to here. Okay. Let's see if we can write that then. So it's increasing from 6 to 8. So I'll go hard bracket 6, soft bracket 8. Then it's decreasing from here to here. So I don't want to double count that 6. So from 0, hard bracket, it was a solid dot up there, to 6. I don't want to count the 6 twice, so I have a hard bracket on one of them, a soft bracket on the other. And then it's also decreasing from here to here, and then from here down. So they have 2 different places it's decreasing. So hard bracket 8, because I had a soft bracket up above, to like 11.5. And then from 11.5 to 12. And that 12 is an open dot. Soft bracket. Ooh, boy, oh boy. This is making my head go cuckoo. Yeah. All right. We're almost done. Last 2 things. Maximum value of the function. So you're looking for your highest y value. What does it appear my highest y value? Y is here. What's my highest value on this graph? Right there? Is that the highest that my graph goes?
Yeah.
So what's that highest value? 160? Let's look at my other one. What's my highest value on this one? 24. Oops. 24. All right, now let's look for our minimum value. What does appear my lowest value on this graph is?
Back up yet, you still got time.
1 minute left. Hey, I'm not going to debate you. Get your stuff out. Okay? Yeah, it's so disrespectful. You don't want to respect my class. You know what? Go talk to your counselor and leave. Get out. You don't want to be here?
I want to be here.
Okay.
I'm going to be out.
Yeah, if you don't want to be in my class, you don't want to respect this class, you can find a different place to be.
There's 1 minute left.
And you're packing up because, it doesn't matter. Thank you for distracting from my educational process of everyone else in this class. My minimum value is where? 70. Okay? My minimum value on this last graph is 0. Bring your books back tomorrow. Have a great day. Take care of one another. None. We'll do it tomorrow.